My name is Drew Batra, and today I'll be teaching this Onshape workshop on behalf of FTC Team 16598 Rebel Robotics. If you aren't aware, First Tech Challenge is a robotics competition. Every year you build robots and then you enter it into competitions. It's really fun, and I would definitely recommend looking into it. Quick shout out to our sponsors. Without them, we wouldn't be able to build robots on a regular basis. You can check out our social media. Even though it's the summer and we're not building robots for the competition, we still have some interesting side projects like a sentry turret with a Nerf gun. And then on our YouTube channel, you can check out recordings of the workshops in case you need to go back to something. Okay, so what are you learning today? You are learning CAD. So what CAD is it is three-dimensional design. And what's great about Onshape is that it's a piece of software that runs in your browser. There's no downloads required, so you can even use it on your school laptops, which in some cases can be like potatoes, but like they're really really bad laptops can run this program since it runs out of your browser. So all you need is an internet connection. So what can CAD be used for? If you have an idea, then you can use CAD for planning. So if you want to build something, you can make a CAD model. That way you have detailed instructions on how to assemble it once after you're designing it, what you need to buy. You can plan in advance. And so what we're going to do in this presentation is I am going to show you how CAD works and the different tools that Onshape has to offer. So this is going to be a high-level overview. That way you'll have these tools in your toolbox, and if you ever need to go back and if you want to learn more into detail about a specific feature, or you forget how to use it, you can always hover your mouse over the tool and it will tell you how to do it. But what's important is that you know that these tools exist. So that's what we're going to be going over in this workshop. Okay, so topics, hierarchy. Okay, so this is Onshape once you log in. And so first off, hierarchy. So think Google Drive, right? You have Google Drive stores files, right? So if I wanted to take notes for a math class, for example, I might create a folder titled math class and then have my notes inside of that folder. So within Onshape, that highest level, you can create a folder. What people typically do is that highest level, instead of a folder, is a document. So I'll just create one. And within that document, you can create parts and assemblies. So if I go back here, this toaster, it's an assembly, right? It's composed of many different parts and sub-assemblies. Like sub-assembly might be like one of the glass panes, right? It's made of a wire and a glass pane, two different parts that come together in an assembly that is part of the overall assembly. So it is a sub-assembly, right? So assemblies are made of sub-assemblies and parts. And within a document, you can have parts, you can have assemblies, and then you can put everything together in one final assembly document. Okay, so I'm going to show you how to make a part, but before I do that, know that you don't have to design this yourself, right? You can go on the internet, right, and go to sites like GrabCAD, Thingiverse, and just grab files off the internet. Like if you are going to be building something and you're going to assemble it and out of off-the-shelf components, then you should be designing with those off-the-shelf components in mind. Like these are some goBilda pieces. They're one of our sponsors, and if I know I'm going to be using goBilda parts in my final design, I want to CAD with those parts. That way, I'm accounting for it. What CAD is, it is planning. So you can always import parts off the internet and then manipulate those in the assemblies. So if you wanted to do that, all you would do is you go to the manufacturer's site, and then usually they have the CAD models with the product, or you can go on sites like GrabCAD and Thingiverse and get it from there. So you download it from there and you click the new and just import, right? And so that's what you do. And so now let's talk about what if I want to make a part, right? If I want to make something custom, okay? So first thing is, you have to be able to know how do you move your screen around, right? It's the view cube, right? So if you know anything about engineering drawings, right, you have your back view, your front view, top view, etc., right? So the basis of design here is you create a sketch on a profile, and then you manipulate that sketch. So, for example, think of this front view, right? Or it's just gonna be easier to show you. So, if I create a sketch right? So let's say this is my sketch, then I can manipulate that sketch through, for example, like an extrusion, and I just turned that sketch into a part, right? So that's the basis of what we're doing here. Okay, so the first step is when you open your software, right? You have a part drawing. Okay, so first thing you need to do is select a plane to sketch on, right? Top, front, or right view. So for example, let's say I want to select top, right? So I select top, and then now I need to be viewing it from the top down since I'm creating a plane on the top sketching field or plane, right? So I click top view, and so now I'm viewing it from the top. So once I'm in the screen, right, I can start doing my sketch, right? And there's lots of different things you can do. You can do lines. There's different shapes here, like I just showed you a rectangle. You can do circles, all sorts of stuff, right? And you can even like make cool shapes, like, or, well, that's just a triangle, but you know, you can make all sorts of different shapes. And so that's what you do with sketches. So once you have a sketch, there are some things you can do with it. There are other features like fillet is an important one. You can choose 2 different pieces, and then you can like round the current corner. So that's a good feature to know. And then there's stuff like the trim feature. And so let's say I draw a line or something here, and I just want to cut that off, right? So I'd use the trim feature, and I can just take out what I don't want. And then there's the offset feature. This is useful when you have, you know, geometry that's not just like a normal rectangle or circle, and you want to have another version of that further out. So or maybe you want it inside, right? So that way you don't have to redraw everything again. You can just use the offset tool. And yeah, so okay. So now I have multiple things, right? Whenever you're done with the sketch, you can just click check and you can exit it, right? And if you can tell which mode you're in by the toolbar up here. So this is the parts toolbar. If I click on sketch, you can see this is a sketching toolbar. So if you exit from the sketch toolbar, you can't use the sketch tools. You have to go back in to view the sketch tools. So just delete that. Okay, so now I'm going to show you extrusion. I just showed you that, but here's something you should know is that whenever you are manipulating sketches, it chooses the closed boundaries. So thinking about like using the paint tool, right? If you have a closed boundary and you want to have multiple, you have to select multiple. So, you know, keep that in mind. Use that to your advantage when you're designing. So that's the extrusion tool. Let's take a look at a couple other tools that you can use. So right here, this is your features list, right? So every time you do something, it'll be in this list, and you can delete it to go back, and you can edit stuff, whatever you want to do, you can do it through here, and it's all accessible. Okay, so let's make another sketch on, let's say, the front plane this time. And I'm just going to show you a top, like a dreidel, like a top. I'm going to show you a new feature called Revolve. Okay, so see how whenever I finish a command, it turns white? When it turns white, that means it's asking you, now you can type in the box if you want to manually set the dimensioning, okay? So dimensions are important if you're designing. That way, if you need something to fit in a specific place or you have something in mind, that's when dimensions come in handy. But I'm just doing an example here, so that's why I'm not paying that much attention to it. But after I do this, right, this is a dimension tool. If I make a sketch and it's like, oh wait, I need to dimension so that this specific area is like, I need it to be that a specific length, I can just change that to 3, and it will manipulate the other parts of it so it matches your dimensions. So sometimes it'll give you an error if you have conflicting dimensions. That what you have to do if you encounter that is you just have to delete one of them. And if you are really trying to go for something, you have to just try to dimension in a different way. Okay, so the revolve feature, you just choose your closed boundary, and then you choose a axis of revolution. So I like this, right? And it'll just revolve it around that axis. So that's a really useful tool for turning sketches into parts. Okay, another way to turn a sketch into a part is, well, first off, I can create another part assembly just by clicking this plus icon. And so what I would do is lofting. Okay, so that's another method. Let's look into lofting. So lofting means you create two sketches and then you just kind of merge them together. It'll make more sense in a second. So let's say I do this, and I want it to be 5 inches by 5 inches. These are arbitrary numbers, by the way. So I have a nice little rectangle there, right? So I don't have to just use these planes, right? There's a plane feature that allows me to create custom planes. So what I do is I choose a plane, and then I can offset and create a new plane a set distance from another plane. So let's say I want it to be 5 inches, right? Then I have, or yeah, let's just see, 4. Okay. So now I've created a new plane, and I can create a sketch on top of this plane. If you're trying to create a sketch, you have to have a plane, and a plane is just like a surface, right? So if I go back to, where is it? Here, this little top here, I can create, even though it's not a set plane, right? There's no plane across the surface of this little top here. I can create a sketch on top of that, right? It'll create a sketch because there is a plane on, like, automatically generated, right? If any type of surface can be used as a plane, but if I want, I can also create just a normal plane, right? But like I just demonstrated. So I create a sketch on top of the plane, and then I can make a shape. Here. Let's say 5 inches or 2 inches. Okay. Then now I have 2 shapes. Okay, and then I can use the lofting feature. There it is, lofting here, and I can see how it will just draw and connect those 2 parts together. Okay, so I have a part. Now, how do I manipulate it? Okay, so you can manipulate parts by, well, first off, you can just go back in and edit the sketch, right? Or what you can do is you can create another sketch. Like, this is another example. Like I said, you can just create a sketch on top of a surface. And let's say I want to create a hole, right? There is a hole feature, but another thing you can do is you can just create a sketch, and then I just showed you extrusion, but you can use extrusion to add and also to remove if you put it in the opposite way and select remove. So that'll create a hole. So there you go. That's a hole. Okay. So there are a couple other things like sweeping, and then of course once you have a part, you can modify it with like stuff like fillets. Here, like you see here, you just select an edge and it'll round the edge. So that's useful to know when you're designing things. And there's stuff like mirroring. You can mirror inside of a sketch or inside of just like once you have a whole design here. Okay, so now that you have your parts, I'm going to just create another part for the sake of the example that we're about to do to teach you how to use assemblies. Okay. Before I do that, is there anything else that was on the topic list? Nothing. That was about it. Perfect. Okay. So let's see. This is just for the example that we're about to do. Okay. See, I don't have to go and click the view cube to view when I'm creating a sketch, but I just have to know that it will, if I select a plane, it will create the sketch on that plane. So let's say 96, right? So that's the depth of my extrusion. And if I ever want to edit it, I can just right click, click edit, and then I can just like modify that. Here we go. Okay, so now I have an assembly drawing. Okay, so this is my assembly drawing, and is there anything else in instances? Okay, so this is your instances list. So watch as I import, right? So first off, when I import, I can import it from stuff within the document by default. These are the parts I just created, right? If I wanted to name those, I can just right click on it, rename, whatever. There's some other stuff like you can do. You can set as a document thumbnail, which is just like, here, if I shape, one sec. If I go to Onshape and I click sign in, you can see that there are little thumbnails here. So next to your name, so you can set as a thumbnail if you wanted to. There's all sorts of stuff you can do once you click that right. You can even export the file of that little part, or you can export the CAD file for the assembly if you need to use it for something else. Okay, so anyway, you can insert from within your part studio, or, well, if you had any sub-assemblies, you can do that here, and that's within the current document. Or you can go in and look, okay, what other stuff do I have on my account, right? So First Robotics, they have or at least one of the teams, they created a set of libraries with parts, right? So you can probably find a library online and then either download it and import it in, or you can request access to a library, whatever the case may be. You have access to parts, even like I told you how to get them off the internet before. So anyway, I click on it and it imports it into the assembly. And if you look here, as soon as I put it in, it added it as an instance. So say I want to insert the other one here. Now, once I have in the assembly drawing, something important to know, especially for the more complex drawings that you're going to do, is if you go back and you edit your sketch, or I mean your part, then it will automatically update within the assembly drawing. Oh, see, I forgot to do that. Whenever you have, like I said before, you got to choose each closed boundary if that's what you want for an extrusion. So important to keep in mind. So like I said, it updated it automatically. Okay, so a good practice to have when you have when you're making an assembly is to choose one part that will always be stationary and fix it. That means, think of it like an anchor, right? Like, so this is the one station. So what a CAD drawing is in some case, it's when you have an assembly, it's a simulation, right? So for example, if I go here, I can twist the propellers. Okay, yeah. Like I can move the propellers, right? So here it's lagged a bit, but yeah, you can see it. You can move the propellers, right? So it's a simulation kind of, and in a simulation, you want to make sure at least one thing is fixed. That way, all your other featured or mates are relative to that fixed object. Okay, so like if I had a vise, and this is a vise, it's like a clamp, and if I was operating in real life, if I turned this little knob here, then I would expect that this clamp to just go forward. However, in a simulation, you have to add these relationships between the parts yourselves. So if I can tell it to rotate and go forward, however, I have to tell this part here, this base, that it has to stay stationary too. So that's why it's good practice to have one part be fixed. So I just fixed this one. And if I ever need to unfix it, I can click that. Okay, so now that you have different parts, you have to say, okay, how do these parts come together? So one of the most common relationships, what we call a mate, is the fastened mate. So for example, like this PVC end cap on this piece of PVC, those are fastened together. There's no reason why those two should move, right? So I would just use fasten mate. So fastening is, you just click the fasten tool, and you choose a face, a point on that face. So in this case, I'm going to choose the center, and then you can choose a point here. So let's say I want to choose a corner here. That's actually a very good thing to note. Whenever you do a relationship, it's going to take the shortest path to that thing. So let me undo that, right? And then if I wanted to do something here, I would have to click on it, rotate it if I wanted the face of this to be touching the face of this, whereas this little knob is pointing upwards, then I have to rotate it first and position it so that the shortest path to the two surfaces I'm trying to fasten fastens it in a way that I have in mind. Okay, so I'm actually glad that happened. Okay, here. So here, and you can see that this pops together. So whatever you select first will be the one that goes towards the second object. Okay, so these two, it's fixed. If I click on it and I drag it, it's not moving anywhere. Okay, so I'll just undo and actually redo. You can see all of the relationships you do, they're going to come up here. So that's just useful for a list, and that way if you can always just delete relationships if you have too many that are conflicting or something, whatever you need to do. Okay, so let's move back here. Okay. So next relationship we're going to go over. Actually, let me just go back to topic lists, manipulation, right? Okay. So next relationship is Revolute. Okay. So take a look at this toaster, right? So say I have a knob and I'm trying to just have it revolve, right? So that's a Revolute mate. I want it to stay in place, but I want it to revolve. The same mate is on the propellers. So what I would do is, again, I would choose the tool. I would choose the face here. And when you choose these faces, they will come together. And then the object that is selected with them will have the properties of that mate. So the Revolute mate, I would go here. I click on the axis that I want. And then I click check. And now this will be able to move here. So it can't go up and down, but it can revolve. So that's one of the mates. Okay. So let's see, what's the next one? Slider mates. Okay. So the slider mate, you can see it in action here. For the lid, right? I want it to go up and down. All right, that's it. Up and down. So by default, whenever you set a mate, it will go infinitely in either direction. So as you can see, I can go infinitely up here, and when I was using the Revolute command, I could twist infinitely in either direction. But if you want it to stop at a certain point, like I don't want the lid to go into the glass panes, then you have to set that in manually. So I'll show you how to do that too. So you can set these manual restraint limits on the mates at any time just by clicking edit. Okay, so Revolute or slider mate. Yeah, so slider is the up and down that I just showed you with the toaster lid. Okay, so same thing. Let's choose the point on the face, they pop together, and we're good, right? And as I just said, it'll go infinitely in either direction, right? But if I don't want it to be crashing in here into overlapping, then what I can do is I can click edit, or I could have just done this when I had it initially up, and I can click limits, and I can set a minimum or a maximum. So let's say, okay. Oh, okay, so I did it wrong, but I mean, you get the point what I'm trying to say. See it now, it'll set the ceiling for it to be at that point. Okay. Okay, and then this one undo until I have the mates down. So sometimes the reason I'm undoing one of the mates before I select a new mate for demonstration purposes is that sometimes if you have multiple different mates, they will conflict. So that's why I'm being careful about that and deleting my previous mates before I add new ones. Okay, so the next one is the planar mate. Okay, so I'm just gonna rotate that. Or actually, here, let me see that. So planar mate. This one will just make more sense if I just show you. I just select two planes, and what it'll do is it just allows you to move on that plane. Okay, okay. Here, let's try this view. So I can't go up or down. I can only move along this plane. So I can move in any direction on that plane, but I can only move on that plane. Okay, so that's another mate that you can do. Okay, what else do we have? Let's see. We have the cylindrical mates. So this is a combination of the Revolute and slider, where you can revolve and go up and down. Same deal. By this time, you should be probably just getting a hang of what's going on. Just choose 2 points on 2 faces. They'll snap together, and then this way I can go up and down. Then I can also revolve. All right, so that's nice. Okay. Okay. Oh, by the way, zooming is done with like your scroll wheel. So that's in case you were wondering. And if you click on that scroll wheel, you can pan. So that's a nice, useful feature for you. And you can just click and drag pieces together. Okay. So another thing that you can do is the pin slot mate. Okay. So I'm not going to demonstrate that one because you don't really use it that commonly unless you have like a locking mechanism or something. But it's just like what it sounds like. You're just like putting a pin in the slot. It just moves inside of that slot. Okay. Let's see. 1:30. Okay, so we are looking good on time. Okay. So one thing that's great about Onshape is it has custom features. Like I just showed you a bunch of tools that Onshape offers, But if there's something that's not there by default, then you can just install the code to do it. Like the surfaces one, beams, that's cool. Wiring, I use that one on the robot. That's always nice for gears, stuff like that, right? And even if they don't have a custom feature that you download to add functionality to your Onshape experience, you can always just code one yourself or grab it off the internet, maybe get off GitHub or something, and hopefully someone has the feature that you're looking for. Okay, let's see. So if you are interested in CAD for 3D printing purposes, then know that there is this organization called Hack the Pandemic. Our team, Rebel Robotics, works with them, and what they do is they 3D print personal protective equipment, and they do all sorts of stuff. So if you're interested in giving back during the pandemic and you have a 3D printer or are willing to do face masks, you can just email us and then we'll put you in touch with them or visit their website. Other learning resources. Okay, so now that you're done with this course, you may be asking, okay, what's my next steps? So what I would recommend is just choose a project and just jump into it and learn just by doing. Onshape does have some tutorials on their website, but they're only useful if you know next to nothing. And since you have at least a little bit of background now that you've completed this workshop, I think it'd just be best if you just opened up Onshape. Maybe you have a project in mind, or maybe you just want to practice and you just Google CAD practice and then some shapes will come up that they want you to make. But if you have a project in mind, that's just the best way to learn. You just learn by doing.